Pharmacognosy. Introduction. Pharmacognosy may be defined as a branch of bioscience which deals in the study of crude medicinal and related products of plant, animal and mineral origins. The crude drugs may be classified according to I. Their alphabetical status, E. The taxonomy of plants and animals from which they are derived, E. Their morphology, IV. The chemical nature of their active constituents, V. Chemotaxonomical status, V. Their pharmacological actions and therapeutic applications. Carbohydrates and related products. The carbohydrates are defined as polyhydroxyketones or polyhydroxyaldehydes or compounds that on hydrolyzers produce either of above. They are grouped into major classes: simple sugars, saccharides, and polysaccharides. Low molecular weight carbohydrates are crystalline, soluble in water and sweet in taste, glucose, fructose and sucrose, while high molecular weight carbohydrates, polymer, are amorphous, tasteless and relatively less soluble in water. A. Starch, cellulose, gums, pectins. Depending upon the chemical structure, saccharides are subdivided as monosaccharides, disaccharides, trisaccharides, tetrasaccharides and polysaccharides. 1. Monosaccharides. These are sugars which cannot be further hydrolyzed to sugar. These are further classified according to the number of carbon atoms in sugar molecules. I. Bioses. They contain 2 carbon atoms. They do not occur free in nature. E. Trioses. They contain 3 carbon atoms, glyceraldehyde. E. Tetroses. They contain 4 carbon atoms, erythrose. IV. Pentoses. They are very common in plants and are the products of hydrolysis of polysaccharides like mucilages and gums. Arabinose, ribose and xylose are the few examples of pentoses. V. Hexoses. They are monosaccharides containing 6 carbon atoms and are abundantly available carbohydrates of plant kingdom. They are further divided into 2 types: aldoses, glucose, mannose, galactose and ketoses, fructose and sorbose. V. Heptoses. They contain 7 carbon atoms, important in the photosynthesis of plant and glucose metabolism of animals and are rarely found accumulated in plants, glucoheptose. 2. Disaccharides. These yield 2 molecules of monosaccharides. For example, sucrose right-pointing arrow hydrolysis right-pointing arrow glucose and fructose. Maltase right-pointing arrow hydrolysis right-pointing arrow 2 molecule of glucose. Lactose right-pointing arrow hydrolysis right-pointing arrow glucose and galactose. 3. Trisaccharides. These liberate 3 molecules of monosaccharides on hydrolysis. Raffinose right-pointing arrow hydrolysis right-pointing arrow glucose plus fructose plus galactose. 4. Tetrasaccharides. These yield 4 molecules of monosaccharide, stachyose, found in banana. 5. Polysaccharides. These give an indefinite number of monosaccharides, depending upon the type of product of hydrolysis. These are further classified as pentosanes and hexosanes. Xylene is pentosane whereas starch and cellulose are examples of hexosanes. Cellulose is composed of glucose units joined by beta-1. 4 linkages while starch contains glucose units, connected with alpha-1. 4 units. Polyuronides, alginic acid, pectin, gums and mucilages are other polysaccharide derivatives. Gums are the pathological products consisting of calcium, potassium and magnesium salt of complex substances known as polyuronides. On prolonged boiling with dilute acids, they yield mixture of sugars and uronic acid. Gums are either hydrophobic or hydrophilic high molecular weight molecules, usually with colloidal properties. Depending upon sources of occurrence, gums can be classified as follows. I. Natural gums. A. Seaweed gum, agar, algin. B. Plant exudates, acacia, tragacanth. C. Seed gums, sugar gum, isafagol. D. Plant extracts, pectin. A. Animal entract, chitin. E. Prepared gums. A. Biosynthetic gums, dextrins. B. Starch and its derivatives, dextrins. C. Cellulose derivatives. Chemical test for carbohydrates. A. Molasses test. The test is positive as well as insoluble carbohydrates. It consists of treating the compound with a naphthol and conch, sulfuric acid, which gives purple color. B. Fellings solution. To the solution of carbohydrate, equal quantity of Fellings solution A and B is added. After heating, brick red precipitate is obtained. Glycosides. Glycosides may be defined in general as the organic compound obtained from plant or animal sources which on enzymatic or acid hydrolysis gives one or more sugar moieties along with non-sugar moiety. The latter is commonly called as aglycone or genin. Chemically, they are the acetals or sugar ethers formed by interaction of hydroxyl group each of non-sugar and sugar moiety, with the loss of a water molecule. The hydroxyl group of aglycone may be alcoholic and in some cases from amine also. The sugar involved in glycosides are of different types, but most commonly, it is beta-D-glucose. The other sugar found are galactose, mannose, rhamnose, digitoxose etc. These are generally classified on the basis of chemical nature of a glycone part as follow. 1. Anthraquinone glycoside, AG, Sena. 2. Cardisterol, glycoside, AG, digitalis. 3. Saponin glycoside, AG, Dioscor. 4. Cyanogenetic glycoside, AG, amygdalin. 5. Flavone glycoside, AG, citrus. 6. Steroidal glycoside, AG, solasodine. 7. Coumarin glycoside, e.g. Soralia. 8. Isothiocyanate glycoside, e.g. black mustard. 9. Aldehyde glycoside, e.g. vanilla. 10. Phenol glycoside, e.g. bayberry. Glycosides are also classified on the basis of linkage across a glycone and sugar part. Basically, all types of glycosidal linkages are occurred by interaction of O group of glycone and hydrogen coming through any of the radicals like CH or SH and NH present on a glycone pair. Hence, by elimination of one water molecule, linkage is formed and the type of glycoside formed is named by putting the element as prefix like C-glycoside, N-glycoside, O-glycoside or S-glycoside. C-glycoside. Some of the anthraquinone glycosides such as cascaricide from cascara and aloin from aloe show the resonance of C-glycoside. Glycone O plus HC, a glycone right pointing arrow, glycone K-glycone plus hydrogen oxide. O-glycoside, they are common in higher plants, e.g., senna, rhubarb. Glycone O plus Ho, a glycone right pointing arrow, glycone 0 glycone plus hydrogen oxide. S-glycoside, it is restricted to isothiocyanate glycosides like sinigrin from black mustard. They are formed by interaction of sulfhydry L group of a glycone and hydroxyl group of glycone. Glycone O plus HS, a glycone right pointing arrow, glycone S, a glycone plus hydrogen oxide. N-glycoside, nucleosides belong to this category where the amino group of base react with O group of ribose, deoxyribose. Glycone O plus NH, glycone right pointing arrow, glycone N, a glycone plus hydrogen oxide. Glycosides are crystalline or amorphous substances which are soluble in water and dilute alcohol but insoluble in organic solvent like chloroform or ether. They show optically activity normally with levorotatory effects. Glycosides do not reduce Fehling solution until they are hydrolyzed. They are believed to participate in growth regulation and protection of plant. Alkaloidal drugs. Alkaloids are nitrogenous base containing at least one nitrogen atom in a ring, possessing definite pharmacological and physiological activities. Alkaloids are colorless. Berberine is yellow-orange in color. Crystalline solid. Nicotine is liquid, insoluble in water but soluble in organic solvent like ether. Alkaloidal salts are soluble in water and insoluble in organic solvents. Alkaloids are generally present as salt, malate, oxalate, citrate, tartrate, etc. They are believed to provide protection to the plants. Most of the alkaloids are optically active. Papain is optically inactive. The chemical tests used for detection of alkaloids are dependent on the characteristics of alkaloids to give precipitates as salts of organic acids or with compounds of heavy metals like mercury, gold, platinum, etc. The different reagents used are Mayer's reagent, potassium mercuric iodide solution, giving cream-colored precipitate, Dragendorf's reagent, potassium bismuth iodide, giving reddish-brown precipitate, and Wagner's solutan, iodine potassium iodide solution, giving reddish-brown precipitate. Isolation and extraction of alkaloids. The extraction of alkaloids is based on their basic character and solubility pattern. Alkaloidal bases are soluble in organic non-polar but insoluble in polar solvent. The salts of most alkaloids are soluble in water but insoluble in organic solvent. The general scheme for extraction of alkaloids can be summarized in powdered drug containing alkaloidal salts like oxalates, tannates defatted with petroleum ether, petrol soluble, fatty material, petrol insoluble extract with 95% alcohol, alcoholic extract, make alkaline with sodium carbonate, New Hampshire 3, CaO, and extract with organic solvent, e.g., chloroform, alcohol insoluble portion organic solvent layer, concentrate and shake with successive quantities of inorganic acid. Aqueous layer contain alkaloidal salts, make alkaline and extract with organic solvent. Organic solvent layer remove solvent. Aqueous layer crude alkaloid mixture purified by fractional crystallization, chromatography, derivatization etc. Alkaloids are classified on the basis of basic nucleus presence in their chemical structure as follows. A. Pyridine pyrrolidine alkaloids, e.g., nicotine. B. Phenanthrene alkaloids, e.g., morphine, codeine. C. Indole alkaloids, e.g., rizaprine, ergometron. D. Quinoline alkaloids, e.g., quinine. A. Isoquinoline alkaloids, e.g., papain. F. Imidazole alkaloids, e.g. G. Phenylethylamine alkaloids. E.g. H. Steroidal alkaloids, e.g., solanidine. I. Ditapene, e.g., aconitin. Structure of some alkaloids. Volatile oils are odorous, volatile principles. They represent essence or active constituent of plant, hence they are also known as essential oils. Chemically, they are derived from terpenes and their oxygenated compounds. They are made up of isoprene units, CH, and usually mono. Cis-Q and diterperes with empirical formula as CGHGC1OH16C15H24 and C20H32, respectively. Volatile oils are liquids. Camphor is exceptional, soluble in alcohol, ether and other lipid solvents and practically insoluble in water. They possess characteristic odor and most of them are optically active. Volatile oils are extracted by steam distillation, solvent extraction and unflourished tech rigways. Hydrodistillation method comprising of water distillation, water and steam distillation is used for extraction of volatile oil from herbal drugs. The fresh material is subjected to hydrodistillation in case of the leaf drugs. Unflourished method is used for extraction of delicate perfume. The fresh flower petals are mechanically spread on layer of fatty material, allowed to imbibe and the exhausted petals are replaced by fresh material. The process is continued till the fatty layer is saturated with volatile principles which are then extracted with liquid solvent. Usul method is used for extraction of citrus oils whereas oil cells in rind are ruptured mechanically using pointed projection by twisting raw material over them in clockwise direction either mechanically or manually. Classification. These are classified on the basis of chemical functional group as follows. 1. Alcohol volatile oil, peppermint, cardamom, coriander rose oil, orange flower oil, sandalwood, etc. 2. Aldehyde volatile oils, cinnamon, lemon peel or anja peel, citronella oil. 3. Ester volatile oils, lavender mustard. 4. Hydrocarbon volatile oils, turpentine oil. 5. Ketone volatile oils, caraway, camphor. 6. Oxide volatile oils, chenopodium, eucalyptus. 7. Phenolic ether volatile oils, anise, fennel, nutmeg. 8. Phenol volatile oils, clove, thyme. Volatile oils are used as flavoring and perfuming agent in pharmaceutical formulations. Foods, beverages and cosmetics. Besides, they are also used as medicinal agents such as carminatives, umbelliferous fruits, anthelmintics, chenopodium, diuretic, juniper, antiseptic, eucalyptus. Counterritant, oil of wintergreen, local anesthetic, clove, sedative, jatamansi, local irritant, turpentine oil, etc. Terpenes, hydrocarbon, and terpenoids are found in all volatile oils of plant or animal origin. Following are few examples of volatile oils along with their terpenoids. Volatile oils: caraway oil, citronella oil, eucalyptus oil, geranium oil, peppermint oil, ginger oil, fennel oil, clove oil. Main terpenoids: carvone and limonene, geraniol, citronellal, cineol, geraniol, menthol, zingigerone, anethole, eugenol. These are classified depending on type and number of rings present in their structure as follows. A. Acyclic terpenoids, open chain structure, e.g., citral. B. Monocyclic terpenoids, one ring structure, limonene, menthol, camphor, pinene. C. Bicyclic terpenoids, two rings in structure, e.g. D. Tricyclic terpenoids. Drugs containing tannins. Tannins are astringent substances, having the capacity to combine with tissue proteins and precipitate them. Chemically, they contain the mixture of polyphenols, generally possessing with O-dihydroxy or O-trihydroxy group in a phenyl ring. Normally, they are fairly high molecular weight compound. Tannans form colloidal solution with water and non-crystalline substances. In solution, they show acidic reaction due to phenols. They are also soluble in alcohol, glycerine, dilute alkalis but practically insoluble in organic solvents except acetone. Tannans show some specific chemical reactions. A solution of tannans precipitates gelatin and alkaloids. B. Tannans are precipitated by salts of copper, tin and lead. C. They are precipitated by strong potassium dichromate solution or chromic acid solution. D. Ferric chloride gives bluish-black or brownish-green color and potassium ferricyanide with ammonia gives deep red color. A. Tannans are precipitated by 2% solution of phenazone. Classification. These are broadly classified into two groups depending on complexity of their chemical nature as follows. I. Hydrolyzable tannans. These are hydrolyzed by acids or enzymes quickly into gallic acid or ellagic acid. On dry distillation, gallic acid and other components get converted to pyrogallol. They respond to ferric chloride solution, producing blue color. The examples of hydrolyzable tannans are gall tannan in nutgall, rhubarb, clove, etc. E. Condensed tannans. They are also called non-hydrolyzable tannans, phlobatanans or promethocyanidins. They are much resistant to hydrolysis. On dry distillation, they yield catechol. These produce brownish-green color with ferric chloride solution. They are distributed in different parts of plants. The green tea and hamamelis leaves, cinchona, cinnamon and wild cherry bark, pale and black catechu contain these type of tannans. Structure. Fixed oils, fats and waxes. There are the reserve food material of plant and animals, those which are liquid at 15.5 degrees to 16.5 degrees Celsius are called as fixed oils, while those which are solid or semi-solid at above temperature are termed as fats. Fixed oil, derived from plant source, occur generally in seeds. They possess the following properties. 1. Fixed oils are thick, viscous yellow-colored liquids with characteristics odor. 2. They are non-volatile and cannot be distilled. 3. They do have food value and can be saponified. 4. They turn rancid on storage due to free acid. 5. Chemically, fats and oils are glyceride of fatty acid. These fatty acid may be saturated, monosaturated or polyunsaturated. Chemical test. Fixed oils or fats can be confirmed by chemical test for glycerine which is produced by their hydrolysis. The test is done as under. CHOCHOH carbon dihydride O plus HOOC CH2 16CH3 stearic acid HOOC CH2 7CH equals CH CH2 CH3 oleic acid HOOC CH2 7CH equals CH2 CH equals CH CH2 4CH3 linoleic acid CH2OOC CH2 16CH3 CHOOC CH2 7CH equals CH CH2 7CH3 CH2OOC CH2 7CH equals CH2 CH equals CH CH2 4CH3 glyceryl stero-oleic linoline. I. Using sodium hydroxide, mix 1 ml of 1% copper sulfate solution and 5 drops of the fixed oil or fat. Then add 5 drops of 10% sodium hydroxide solution. A clear blue solution is obtained which show glycerine is present in the sample. Using sodium hydrogen sulfate. Take 5 drops of the sample in a test tube and add a pinch of sodium hydrogen sulfate. Pungent odor develops, indicating the presence of glycerine. Waxes are viscous solid substances with characteristic waxy luster. Chemically, these are esters of fatty acid with high molecular weight monohydric alcohol, such as cholesterol, cetyl alcohol etc. They are insoluble in water but soluble in most organic solvents. The esters in waxes are generally more resistant to saponification than glycerides of oils and fats. They are obtained from vegetable and animal sources. 1. Vegetable wax, sea salt wax, carnauba wax, Japan wax and bayberry wax. 2. Animal wax, spermaceti, beeswax, wolfed. The difference between fat and waxes is that fats may be saponified by either aqueous or alcoholic alkali but waxes are only saponified by alcoholic alkali. Resins are transparent or translucent solids, semi-solids or liquid substances. Most of them are heavier than water. They are insoluble in water but soluble in alcohol, volatile oils, fixed oils and non-polar organic solvent, ether. These are usually formed in schistosoneous cavities or ducts as end products of metabolism. Chemically, these contain organic acid, alcohol, esters and neutral resin. Depending upon the chemical composition, these are classified as A. Acid resins, colophony, B. Ester resins, benzoin, C. Resin alcohols, balsam of Peru. Resins and oils in homogeneous mixture are called oleoresins, e.g., capsicum. Oleogum resins are the homogeneous mixture of volatile oil, gum and resins, e.g., asafoetida, gugul. If the resins contain benzoic acid and or cinnamic acid, it is called as a balsam, e.g., balsam of Tolu. Isolation of resins. Pharmaceutical resins are obtained from the plants and animals by one of the following methods. 1. By extraction with alcohol and precipitation with water, jalap, podophyllum, ipomia. 2. By distillation for separation of oils, copoeba, colophony. 3. By heating the plant part, guaiacum. 4. As plant exudates by incisions, myrrh, asafoetida, balsams, etc. 5. By collecting fossil resins, kapal. 6. By processing the encrustations, shellac. Resins contain wide variety of compounds as shown below. Structure.